Welcome to Future Forward, where we explore the technologies shaping tomorrow. I'm Alex.
And I'm Ben. Today we're tackling a topic that feels like it's pulled from the pages of a sci-fi novel,
Right.
but is getting closer to reality every day. The end of organ transplant waiting lists.
It's a heartbreaking reality that for every person who receives a life-saving transplant, many more are left waiting. But what if we could remove the need for a donor altogether?
Okay.
This is the incredible promise of 3D-printed organs.
It sounds almost magical.
Yeah.
So let's break it down. When we say 3D printed organ,
Yeah.
what are we actually, talking about?
So it's a process that mimics standard 3D printing,
Okay.
but with a revolutionary twist. Instead of ink or plastic,
Right.
the machine uses a special substance called bioink.
And this bioink is the key. It's a hydrogel packed with living cells, often the patient's own stem cells, along with the proteins and nutrients they need to thrive. The printer gets a highly detailed digital blueprint of the organ, say a kidney,
Wow.
and then meticulously prints it, one microscopic layer at a time.
And once the basic structure is printed,
Okay?
it's not immediately ready. It goes into a special device called a bioreactor.
A bioreactor, right?
You can think of it as an incubator that simulates the conditions inside the human body. It provides oxygen and nutrients, helping the cells multiply, organize, and mature into functional tissue.
The implications here are just staggering.
They are.
I mean, you're talking about solving two of the biggest problems in transplantation at once. First,
Yeah.
the sheer lack of organs.
Exactly. The wait list has over 100,000 people in the U.S. alone.
Wow.
This technology could, in theory, create an unlimited, on-demand supply.
But the second point is, for me, even more of a game changer.
Okay.
Eliminating organ rejection. If the organ is printed using the patient's own cells,
Right.
their immune system just recognizes it as self.
Right.
No attack, no rejection.
And that means no need for the powerful immunosuppressant drugs that transplant recipients have to take for the rest of their lives.
Yeah.
Drugs that carry their own risks and costs. It's a truly personalized solution.
So where are we right now on this journey?
Good question.
Are we surgeons prepping to transplant a 3D printed heart anytime soon?
We're not quite there with complex organs like hearts or livers for human use.
Okay.
But the progress is real. Scientists have already successfully printed and transplanted simpler structures. Lab-grown bladders, created using similar principles,
Oh, really?
were first transplanted into patients over 2 decades ago and are still functioning.
And I've seen reports on 3D printed skin grafts for burn victims,
right.
which is a huge step. They've also created cartilage for ears and joints, and even mini livers.
Right.
Not for transplant, but for pharmaceutical companies to test drug toxicity on functional human tissue without risking a human life.
That's right. And speaking of hearts, there was a major milestone in 2019 when a team in Tel Aviv printed a miniature heart from human cells. It was about the size of a rabbit's, but it could contract and beat. It was proof of concept that it's possible to print an organ with all its complex cells and blood vessels.
Curse, it's not a straight road from a rabbit-sized heart to a fully functional human one.
Yeah.
The complexity of the vascular system,
Oh, yeah.
all those tiny arteries and capillaries that deliver blood, is one of the biggest hurdles. How do you print something so intricate and ensure it works?
That's the billion-dollar question. And it's not just a technical challenge. There's also the long road of regulatory approval.
Right.
I mean, the FDA has approved 3D-printed medical devices like implants.
Okay.
But a living biological organ is a whole new frontier with immense safety and ethical considerations.
Still, the momentum is undeniable. Experts are projecting that we might see simpler tissues in routine clinical use within the next 10 years, with more complex organs potentially following in 20 years.
It represents a fundamental shift in medicine, moving from a model of replacement to a model of regeneration.
Regeneration, wow.
It's not just about swapping out a broken part. It's about creating a brand new, perfectly matched one from scratch.
Yeah.
For the millions of people affected by organ failure, This technology isn't just an innovation, it could be the miracle they've been waiting for.
It truly redefines what we think is possible. Now, here's a question we'd like you to think about. If we can one day print organs on demand, should this technology be available to everyone equally, regardless of wealth or lifestyle choices that may have contributed to their condition, and who gets to decide?